So a very delayed upload to this senior Kangaroo. It happened quite a while ago for my standards. I'm usually a lot earlier than this, almost a month later. But I was busy, I was busy and I was taking a break. So let's finally do it. Now, unknown month and an unknown year. So I think there are four different lengths of month available in our stupid calendar: 28, 29, 30, and 31. So this is a regular February, a leap year February, and then just the other months. So if the seventh day is a Tuesday, that means the Tuesdays happen on the 7th, the 14th, the 21st, and the 28th. Now, if the 28th is a Tuesday, then that means that the next Tuesday, well, Wednesday will be the 1st, which means the next Tuesday will be on the 6th. No, it won't. It will apparently be on the 7th, of course, on the 7th, because you just add 6 on, so you get to the 7th. And then 29th, of course, just count back one because you've got this extra day in this month. So that's one less in this month. So that'll be the 6th. And then the 30th will be the 5th. And then so on. And then just do 7 times 6 times 5 times 4 because that's what they're asking you to do. I don't like questions like that at all. I think they're dumb. I didn't bother working out this over here. I just looked at this chain up here for question 2 and just said, well, which is the biggest over there? This is 2 minus nothing plus 4, which is 6. This is 2 plus 0, which is 2. This is 2 times 0, which is 0, plus 8, so that's going to be 8 there. And this is 2 times 6, which is 12. So this is 12 times this. So this last one's the biggest. So 12 plus 11 times 20 is going to be this here. And yeah, okay. For this question, just need to use a tiny bit of logic to get the question done very quickly, which is that if you hit a stone and it breaks into 8 pieces every time, that means every time you do a hit, you're increasing the total number of stones by 7. Because you essentially lose the one that you're hitting, but then gain 8. So you gain a net total of 7. So if you start with 11 and you do one hit, you then get to 18. And then if you do one hit, you then get to 25 and so on. So this is a sequence of the form 7n plus 4. And we're just going to have to try and get as close to 1,000 as possible. So just sub in n values such that you get quite close. I tried 150, which got me too far, but then just take away some multiple of n, like 56, and you end up with 998, which would be the most number we could get up to if we're going to be less than 1,000 every time. Okay, 35 can be written in as the sum of 4 different primes. All we have to do here is write down the primes and then notice that the reason that 35 did this is because 13 and 17 adds to make the same thing as 11 and 19 because one is 2 less than this and the other is 2 more. So let's do that but with just lesser primes. Let's start with 2 and 3 again, but then find a sequence in here, and I think it's pretty easy to see. 5 and 13 and 7 and 11 add to the same thing. No, they don't, sorry. Yes, they do, because 7 is 2 more than 5 and 11 is 2 less than 13. So that will work and it makes 23. And in Kangaroo, you always have 3-digit answers. And if it's 2, then you just start with a 0 and we're all good. Anyone who's watched my Tomorrow series did this question instantly because all the mod function does, if you put a negative into it, which you are doing here because root 1, 2, 3 is about 11, and 11 minus 4, 5, 6 is very negative. All the mod function does is times the whole thing by -1 and then just goes away. So let's just times this by -1 and make the mod go away. And now this is clearly a positive number and the mod function doesn't do anything if it's a positive number. This is actually just being described for you down here, which means you get this. Of course, the roots cancel and you just add up the numbers and you get your answer. Now, if you've done your homework, this question shouldn't have been too bad. The homework for every math challenge, of course, is to learn the prime factorization of the year the math challenge is in, which is this here. And now we just need to try and find some way of combining these primes together to make 2 factors that have a difference essentially of 70. And it's not too hard to eventually spot 4 and 23 and 2 and 11. It's really just a case of trying to get the same last digit right to have a difference of 70, and then it just works. So x minus 9 is 2 and x minus 22 or plus 22 are the answers. And yeah, now of course we have b is that and a is that, and we just follow the formula and we have our answer just there, and it will be good to go. Didn't really understand question 7 because it's just kind of trivial. Half AB sine C. I guess you need to know what sine 120 is. It's symmetrical around 90, so it's the same as sine 60, which is root 3 over 2. You just put those together, you square it. I guess it's a bit of maths to work out how many 16s go into 675. I did it just by trial and erroring multiplication. Eventually you find 42 is the maximum thing that fits in and is closer than 43 is going to be because it's only 3 away. So the answer is that. With these ones, of course, you just run through it and just say, okay, well, I want the maximum number of these to be true. So let's start with a truth. This game can be a draw with Glasgow scoring because it could be 1-1. Glasgow can't win if it's a draw, so that's got to be false now. Glasgow will not lose is true because they drew according to the first statement. and exactly 5 goals will be scored. Now that's not possible because you can't draw with 5 goals being scored. So that we only have 3 truths here. So now we go back to the top and we say, okay, what happens if you try a false there instead? Glasgow can score if it's not a draw. Of course, they could win 5-0. Glasgow could win because they could win 5-0. Glasgow could not lose because they could win 5-0. And 5 goals could be scored because they could win 5-0. So this will be 4 truths, and that's the most we're going to get because, of course, when we tried a truth at the top as well, we didn't end up with 5 truths. So therefore, we're done. Question 9 then, we just need to do some nice factorising. Factorise out 24 to the power 2024. That leaves behind a 1 here because this times 1 is this, and just a 24 because 1 more 24 would get you to 2025. Now this of course is 25, which factors to 5 times 5, and 24 is just 3 times 2 cubed, right? So basically n is a number with an absolute ton of 2's, an absolute ton of 3's, and 2 5's. Which factors does it have between 1 and 25? Well, clearly 1 because everything does. It has 2 because it has loads of 2's. It has a 3 because it has loads of 3's. It has a 4 because it's got loads of 2's. It's got a 5. It's got a 6 because 6 is just 2 and 3 and it's got loads of those. It doesn't have a 7 because 7 is prime and it just doesn't have that particular prime number. It has an 8 because 8 is just 2 cubed and then has loads of 2's. It has a 9 because it's got loads of 3's and 9 is just 3 cubed. It has a 10 because 10 is 2 times 5 and it has a 5 and a 2. It doesn't have an 11 because 11 is prime. And we just keep going in that vein. And of course you miss all the primes, and you also miss some multiples of other primes until you get all the way there, and then you add them up and you get 147. Question 10 then. So the sides or the edge length of this cube is 12. So this distance down to this corner here is 6, and so is this one here. Little right angled triangle here of 6 squared plus 6 squared square rooted is 6 root 2. So the edge length of this kind of shape here is 6 root 2 everywhere. So 6 root 2, 6 root 2, 6 root 2. So I can work out the area of this triangle here by doing a half times 6 root 2 times 6 root 2 times sine 60. Sine 60 is root 3 over 2 as described earlier. Lots of things cancel out, which is nice. You get 18 root 3. There are 8 of those faces, I think, 4 on the top, 4 on the bottom. So times that by 8 and we end up with 144 root 3. So A is 144 and B is 3, and we just type that in. To this, I say type that in because I was using my phone calculator for things like this, because I was really bored and couldn't be bothered to do that kind of maths on my own. 24 factorial over 20 factorial, most people will know this, but of course you can just cancel the entire 20 factorial list from top and bottom and just leave yourself with this top bit here. So this is just this. And now we need to work out which square that's very close to. If you do 24 times 21, you notice it's this, and 23 times 22 is that. So essentially we're doing this times this, which has got to be 505 squared, right? Basically, with a 1 away. And you can prove that algebraically if you really want to. You can notice that if you just add in an extra 1, that's the same as the middle number squared. So this is definitely 505 squared minus 1, and we should be good to go. Okay, here we need the formula for the volume, which is a third pi r squared h, so that's fine. The surface area is pi r L plus this base pi r squared. Now pi r L refers to the slanted height of the cone, so I need to do a bit of Pythagoras to find that, just by doing this thing squared plus this thing squared square rooted, which gives me this. That conveniently becomes that, which roots cleanly. You put that in to both of them, actually, I guess, to get 4 pi r squared. And so that's the total surface area, which is what it wanted us to describe. If we do V over A, we get this. The r's cancel, the pi's cancel, the 12 goes on the bottom. I decided to square everything here to get this, and then not times by 144, obviously, but divide by 8 to get this. Then I square rooted everything again to get down to here, because I recognize these as square numbers, and times by 12, and you end up with 300 is your answer. Just a bounds question here. So this to the nearest integer is 39.5 to 40.5, and then 9.5 to 10.5. Speed is distance over time, which means time is distance over speed. And to make the biggest time, we do big over small, and smallest time is small over big. So we just do that and take them away because it's asking us for the difference. I decided to double both those to give me whole numbers, and then I just searched for easy ways of doing this, but I just couldn't find anything that was worth doing. So you just have to get on with this times this minus this times this. This times this is nice because, as we saw in the previous question or two, it's just 20 squared minus 1. So maybe that was a little Easter egg that they were putting in there to help you do that nice and fast. But doing this times this minus this times this is just annoying. Some algebra proves that it's just something to do with the middle number being multiplied, I guess, in some way. But I couldn't be bothered to actually do it. Anyway, that's a over b, so then we just put this in from here, and we get our answer eventually. Question 14 then. So yeah, firstly, you can figure out that f of 0 is 1. That's actually not very helpful, but it is at least helpful that it sort of tells you that, like, there's no way of breaking up 24 that's actually useful, because if you did it like 1 and 23, you don't know f of 1 and f of 23. So even if they equal 4096, that's not helpful, except for the one way of doing it which is helpful, which is f of 12 plus f of 12. Sorry, f of brackets 12 plus 12. And the reason that's helpful is because it becomes f of 12 times f of 12, which is f of 12 squared. This is a bit like why completing the square is helpful. Like it makes something that you can later square root, which is really useful. Of course, that still equals 4096, and we can square root that. 4096 is 2 to the power 12 because it's 4 lots of 1024, which is 2 to the power 10. So that's going to be 2 to the 6 all squared, which is 64 squared. So that's going to be rooted to 64. And now that we've got that, we can do exactly the same thing again to find 6, because we can root 64 for 8. And now, of course, we know f of 12, f of 6. If we just times those together, we're going to get f of 18 by the definition. And we'll end up with our answer. I did it all in twos because it's fun to do it like that, I guess. Another one of these questions, there's actually been 2 of these. We just run from the top. We call Ada a liar first, which means that she is lying about neither carrying the most or least. So that means she carries either the most or least. That means we want 3 truthers now, because we know exactly one is lying. So if Bryn is telling the truth, then he's got one of these 3 things. If Chris is telling the truth, then he's got this one, which means the other 2 can't have the 444s, which means that Ada must have 111. And Debbie is telling the truth, which means she's got 111, which of course is not going to work because Ada must have 111 in this scenario. So Ada is not the liar. So let's go to the next one. Let's say Bryn is the liar. And then we write out the things that they could have based on what they're saying, and we look for consistencies. Here, 2 people must have 111, so that's not going to work. So we instead call Chris the liar, which gives us these results. And I think there's a consistent thing we can do here, right? We can say that he's got the 444, he's got the 111, and then just split the 2 to 2 and the 3 to 3 between these 2 people. So Chris is the liar. Just to be absolutely sure, you could make Debbie the liar and verify that no one can have the 111 here, so it doesn't work. So therefore Chris is definitely the liar. Chris has 5 letters, so therefore it's 005. I think I just did this with trial and error. Just call this y, this z, and this t, and we must know that from this square, 100 plus y plus 500 plus x, which is this, equals the square sort of facing us, 100 plus, sorry, square back here, x plus 500 plus z plus t. All that got me was that 100 plus y is z plus t, which I don't know whether there's like a super trivial, obvious way of just realizing that straight away. But that was enough for me. I just couldn't be bothered to do any more work after that. Because just set y to be like 400 to make these to add up to 500, so these 2 also have to make 500, so just make them 200 and 300. And swap it over if this doesn't work, just to try it again. X has to be 600 here, but that makes the back side of this shape over here much too big, so that doesn't work. You can't make y 500. Swapping these over doesn't help because the back of the shape would be way too big still. So make y 600 just to try and make this front much bigger. That makes 700 to make these 3 and 400. Again, swap if necessary if it's not going to work, but then x just has to be 200, and it works out that this is fine and works well. So yeah, all good. Question 17. So we have a parabola at 24, and of course you can factorize to x minus 6, x minus 4, so x ends up 6 and 4. So it looks like this. And now we have a circle around these 3 points. Now, there's actually quite an easy way of doing this question, as long as you're very good with your geometry. So the circle, I'm going to argue, has to have center at x equals 5. And the reason for that is that when the circle goes through these points like this, the x-axis here is actually a chord of the circle. And a radius going down to the edge like this must meet a chord like this at 90 degrees, like it must bisect. There's some circle theorem that discusses that. And so, yeah, I argue the center must be 5 based on that. Now, also, the parabola runs through the points like this, and the parabola is also symmetrical around its own turning point. That's just what quadratics do. Now, the turning point in the quadratic is still is 5, of course, because it's in between the 2 turning points, which means that the quadratic is also symmetrical around this radius, this line here, which means that the other point up here that has a height of 24 must have an x point of 5 plus 5 to make 10. Um, and yeah, that's all I said. And then I can just say, well, the distance between this point and the origin is 10 squared plus 24 squared square rooted. Notice that it's I don't know why I wrote that twice. It's a scaled up version of the 5, 12, 13. It's 10, 24, 26. The answer is 0, 2, 6. So yeah, that's all I did for that question. Question 18. Okay, to do this question, I'm just going to code these as remove blue, remove red, add blue, add red. Now, basically these things have to come in pairs. You need to remove a blue counter only to then add it in somewhere in those 4 moves. So obviously if you remove blue, add blue, add blue, that would be a sequence of 4 moves that would work. But so would remove blue, add blue, remove blue, add blue. Like you could swap those orders around in any way. You could also add the blues in first because you've got loads of spares to do so, as long as you bring those adds and remove blues in pairs, and likewise adds and removes red. So the first thing I thought was, okay, let's just do one of each of these 4 things. That will balance everything out. And the probability of doing that is 4 factorial times 1 quarter to the power 4. Now 1 quarter to the power 4 is just because you're doing, each of these comes with the probability a quarter, and you're doing 4 of them, so it's a quarter times a quarter times a quarter times a quarter. 4 factorial comes from the fact that any 4 of those, we can have any order, right? We can have any of them for the first thing, any of them for the second, any for the third, except for the one that we've done already. So it's 4 times 3 times 2 times 1 as our choices if we need all 4 to happen. Now, of course, this simplifies a little bit to this because this is the 4 cancels with one of these 4s and you get 3 factorial, which is 6, and then you get this. Now, the other way of doing it is to, instead of doing one of each, just do blue things. So do a couple of of blue removals and a couple of blue additions. So something like this. But again, those can come in any order. And so the order is given by this. This is a bit like the Mississippi game. If you don't know how to arrange words like Mississippi, very useful here. There was 4 of these things, but there are 2 repeats each twice, so it's 4 factorial over 2 factorial, 2 factorial. Just search Mississippi, Mississippi maths, if you haven't seen rearrangements of words like that, because I guarantee there'll be something on it. Anyway, and then of course still a quarter to the power 4, you can work this out, ends up being this, and likewise you can just do that with the reds instead, and it's just the same thing, you get the same thing. Times this by 4 to get it same denominator, and then just add the rest together. Cancel down a couple of times and then follow the maths that they're asking you to do, and we'll end up with our answer to 18 as well. Question 19, super proud of myself for spotting this one because I don't know how difficult it gets made if you don't spot this trick. But draw a line from M to T, and now let's do some arguing here. If we call the side length of the hexagon x, Q to T is 2x. And the reason for that is that a regular hexagon is just 6 equilateral triangles pasted together. So you can draw a line from like P to the center to U, and it will just be x plus x there. So it's 2x across. The reason I'm arguing this is because, of course, if this is y, then the whole height of the hexagon is 2y, kind of obviously. Which means that the area of RMS, we can argue now, based on my definitions, is a half times x times 2y, which is 920 because that's what they've given us, just a half times base times height. But also QMT is also a half times base times height, which is a half times 2x times this y here. But of course the 2, it doesn't matter where it goes, so this must is the same algebra, so it's still 920. So QMT is still 920, as well as RMS. Now what I'm going to say next is MIJ. Now MIJ is just RMS, but half as big, right? Because it's got half the height. It's clearly similar because of, equal angles here and shared angle here. It's just half the length. But of course, if it's half the length, that means it's a quarter of the area because of how scale factors work in 1D, 2D to 3D. So it's a quarter of 920, which makes 230. But of course, I can just remove that from QMT here and divide by 2 because these areas are going to be the same. And so I'll then just end up with 345, which will be my correct answer. And lastly, number 20, look down the list and find the one that seems most restrictive. 1 down for sure does. 1 to the power 6 plus 2 to the power 6 is 65. You can't use 3 to the power 6 because that's bigger than 100, and notice this is a 2-digit number for 1 down. And you could use 0 to the power 6, I guess, and try and go for 64. I didn't actually think of that at the time, but it turns out my answer was right, so I never actually bothered to go fix it. Maybe there's another reason why we... I don't know whether it says whether it accepts 0 to the power 6 as a 6th power. I don't know whether it allows that, but also maybe there's just another reason that breaks down later on anyway. But for now, we'll go with this. 1 across is now a prime. The only 2 primes starting with a 6 are 1 and 7. So that's cool. Let's put those down. And then next one we can do maybe is 2 down, because we now know that 2 down starts with a 1 or a 7. So 101 less than that, we need to look for square numbers that start with a 2 or an 8, basically. I say basically because there is one sneaky one, which is 900, which take away 101 gets you down to 799. So we do need that one. Anyway, so let's take away the 101 and we end up with these options for the 2 down, except we can't use 0 according to the rules, so that one goes away straight away. And then we look back at the next clue, shares a 2-digit common factor with 1 down. Now 1 down is 65, which is just 5 times 13. So the only 2-digit factor it could share is 13 or itself 65. Either way, it's a multiple of 13, and that's 5 across. Now 5 across ends with the same thing 2 down did, which is here. So if we list out the multiple of 13, we notice that the things that these start with have to be the same as the things that these end with. Now there's nothing that starts with a 4 here, right? So this one can't work. And there's nothing here that starts with an 8, so this one here can't work. And now the only things that these end with are 5 and 9, so we can only have the one that starts here at 5 or 9. So that's either the 52 or the 91. And it's at this point that I just decided to draw both cases out. So this is the case here, where I'm going with 1, 5, 5, and 52. And then here I'll do the case that goes 7, 9, 9, 91. Now how do we figure out which one is right? Well, what we do is look at this last clue here. The sum of all the digits is 4 down. So if we call the first digit of 4x, the sum of all the digits is just all these things added together, obviously. But that's got to equal xd2, right? The number made from x and 2, which is 10 lots of x plus 2, because that's how, what's it even called? Place value? That's how place value works. And we try and solve this equation, but it doesn't give us a whole number. So we discard it, because x, of course, has to be a whole number. And then we do what I said, which is try the other version of the puzzle and put that in, and you end up with x is 4, which is great. So therefore x is 4. And the answer across the middle there is 594. Thank you so much for watching, and I'll see you next time.